So let's talk a bit about translations. Transitions are actually very simple, and it's basically moving an image in one direction. It can be left, right, up, down, or even diagonal if we implement an X and Y translation at the same time. So to perform a translation, we actually use OpenCV's CV2 warp affine function, but that function requires what we call the translation matrix. So without getting into too much high school geometry, a translation matrix basically is in this form and takes an X and Y value as these elements here. Now what this represents here is a shift along the X axis horizontally, and Y is a shift along the Y axis vertically, and these are the directions each shift takes place. So images always start off being at the top left corner, and we translate it in any direction using the translation matrix here. So let's implement this in code quickly. So let's implement translations using OpenCV now. So going through line by line, I'll quickly show you what's being done here. The important thing to note is that we're using the CV2 warp affine function, and that's being implemented down here. So quickly going through, we load the image as we've done before. We extract the height and the width of the image using the NumPy shape function, taking only the first two elements of the shape array that it returns. Next, I have a line here where we extract quarter of the height and quarter of the width. That's going to be our TX and TY value in our translation matrix. That's the direction, or sorry, the amount of pixels we're going to shift the image. And we actually use NumPy float32. That actually defines the array, the data type for our translation matrix. And by using some square brackets here, we actually created our T matrix here. It may or may not be important for you to understand this, but just take note of the form of this T matrix here. So the warp affine function takes our image that we loaded in, the T matrix that we created, and our width and height as a tuple. And it actually returns the translated image. So let's actually run this and see what it looks like. Ta-da! This is our translated image here. As you can see, it shifted the image in the X direction, a quarter of the initial dimensions, and similarly for the Y dimension, but just downward. So it's important to note that we should just take a look at the T matrix to give you an understanding of what we have done here. So this is exactly what we wanted in our T matrix. It's 1, 0 in this order, and TX and TY. This being a quarter of the height and a quarter of the width, respectively.